Dark, cold, and whipped by supersonic winds, ice giant Neptune is the 8th and most distant planet in our solar system. More than 30 times as far from the Sun as Earth, Neptune is the only planet in our solar system not visible to the naked eye. In 2011, Neptune completed its first 165-year orbit since its discovery in 1846. Neptune is so far from the Sun that high noon on the big blue planet would seem like dim twilight to us. The warm light we see here on our home planet is roughly 900 times as bright as sunlight on Neptune. NASA's Voyager 2 is the only spacecraft to have visited Neptune up close. It flew past in 1989 on its way out of the solar system. The ice giant Neptune was the first planet located through mathematical calculations. Using predictions made by Urban Leverrier, Johann Galle discovered the planet in 1846. The planet is named after the Roman god of the sea, as suggested by Leverrier. Neptune is very similar to Uranus. It's made of a thick fog of water, ammonia, and methane over an Earth-sized solid center. Neptune has a thick, windy atmosphere. Its atmosphere is made of hydrogen, helium, and methane. The methane gives Neptune the same blue color as Uranus. Neptune has 6 rings, but they're very hard to see. Neptune's environment is not conducive to life as we know it. The temperatures, pressures, and materials that characterize this planet are most likely too extreme and volatile for organisms to adapt to. With a radius of 15,299.4 miles, 24,622 kilometers, Neptune is about 4 times wider than Earth. From an average distance of 2.8 billion miles, 4.5 billion kilometers, Neptune is 30 astronomical units away from the Sun. From this distance, it takes sunlight 4 hours to travel from the Sun to Neptune. One day on Neptune takes about 16 hours, the time it takes for Neptune to rotate or spin once. And Neptune makes a complete orbit around the Sun, a year in Neptunian time, in about 165 Earth years, 60,190 Earth days. Sometimes Neptune is even farther from the Sun than dwarf planet Pluto. Pluto's highly eccentric, oval-shaped orbit brings it inside Neptune's orbit for a 20-year period every 248 Earth years. This switch, in which Pluto is closer to the Sun than Neptune, happened most recently from 1979 to 1999. Pluto can never crash into Neptune, though, because for every 3 laps Neptune takes around the Sun, Pluto makes 2. This repeating pattern prevents close approaches of the two bodies. Neptune's axis of rotation is tilted 28 degrees with respect to the plane of its orbit around the Sun, which is similar to the axial tilts of Mars and Earth. This means that Neptune experiences seasons just like we do on Earth. However, since its year is so long, each of the 4 seasons lasts for over 40 years. Neptune has 14 known moons. Neptune's largest moon, Triton, was discovered on October 10, 1846, by William Lassell, just 17 days after Johann Gottfried Galle discovered the planet. Since Neptune was named for the Roman god of the sea, its moons are named for various lesser sea gods and nymphs in Greek mythology. Triton is the only large moon in the solar system that circles its planet in a direction opposite to the planet's rotation, a retrograde orbit, which suggests that it may once have been an independent object that Neptune captured. Triton is extremely cold, with surface temperatures around -391 degrees Fahrenheit, -235 degrees Celsius. And yet, despite this deep freeze at Triton, Voyager 2 discovered geysers spewing icy material upward more than 5 miles, 8 kilometers. Triton's thin atmosphere, also discovered by Voyager, has been detected from Earth several times since, and is growing warmer, but scientists do not yet know why. Neptune has at least 5 main rings and 4 prominent ring arcs that we know of so far. Starting near the planet and moving outward, the main rings are named Galle, Leverrier, Lassell, Arago, and Adams. The rings are thought to be relatively young and short-lived. Neptune's ring system also has peculiar clumps of dust called arcs. 4 prominent arcs named Liberty, Equality, Fraternity, and Courage are in the outermost ring, Adams. The arcs are strange because the laws of motion would predict that they would spread out evenly rather than stay clumped together. Scientists now think the gravitational effects of Galatea, a moon just inward from the ring, stabilizes these arcs. Neptune took shape when the rest of the solar system formed about 4.5 billion years ago, when gravity pulled swirling gas and dust in to become this ice giant. Like its neighbor Uranus, Neptune likely formed closer to the Sun and moved to the outer solar system about 4 billion years ago. Neptune's atmosphere is made up mostly of hydrogen and helium with just a little bit of methane. Neptune's neighbor Uranus is a blue-green color due to such atmospheric methane, but Neptune is a more vivid, brighter blue, so there must be an unknown component that causes the more intense color. Neptune is our solar system's windiest world. Despite its great distance and low energy input from the Sun, Neptune's winds can be 3 times stronger than Jupiter's and 9 times stronger than Earth's. These winds whip clouds of frozen methane across the planet at speeds of more than 1,200 miles per hour, 2,000 kilometers per hour. Even Earth's most powerful winds hit only about 250 miles per hour, 400 kilometers per hour. In 1989, a large, oval-shaped storm in Neptune's southern hemisphere, dubbed the Great Dark Spot, was large enough to contain the entire Earth. That storm has since disappeared, but new ones have appeared on different parts of the planet. Some of the earliest recorded observations ever made through a telescope, Galileo Galilei's drawings on the 28th of December 1612 and the 27th of January 1613, contain plotted points that match up with what is now known to have been the positions of Neptune on those dates. On both occasions, Galileo seems to have mistaken Neptune for a fixed star when it appeared close, in conjunction, to Jupiter in the night sky. Neptune's internal structure resembles that of Uranus. Its atmosphere forms about 5 to 10% of its mass and extends perhaps 10 to 20% of the way towards the core, where it reaches pressures of about 10 GPa, or about 100,000 times that of Earth's atmosphere. Increasing concentrations of methane, ammonia and water are found in the lower regions of the atmosphere. The mantle is equivalent to 10 to 15 Earth masses and is rich in water, ammonia and methane. As is customary in planetary science, this mixture is referred to as icy even though it is a hot, dense fluid, supercritical fluid. This fluid, which has a high electrical conductivity, is sometimes called a water-ammonia ocean. The mantle may consist of a layer of ionic water in which the water molecules break down into a soup of hydrogen and oxygen ions, and deeper down superionic water in which the oxygen crystallizes but the hydrogen ions float around freely within the oxygen lattice. At a depth of 7,000 kilometers, the conditions may be such that methane decomposes into diamond crystals that rain downwards like hailstones. Scientists also believe that this kind of diamond rain occurs on Jupiter, Saturn, and Uranus. Very high-pressure experiments at the Lawrence Livermore National Laboratory suggest that the top of the mantle may be an ocean of liquid carbon with floating solid diamonds. The core of Neptune is likely composed of iron, nickel and silicates, with an interior model giving a mass about 1.2 times that of Earth. The pressure at the center is 7 MBAR, 700 GPa, about twice as high as that at the center of Earth, and the temperature may be 5,400 K. Thanks for watching. If you liked the video, press the like button, subscribe our channel and press the bell icon to get the next video notification. See you in next space adventure.